following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to wrap up chapter 8. We're going to look at section 8.9. Tonight's homework is section 8.9 as well as the chapter review. Tomorrow, Friday, we'll review for the test. The test will be on Monday. So on Monday, we will not have a regular class meeting. Okay, well, let's go ahead and get started. The topic in section 8.9 is called variation. We're going to look at 3 types of variation today. The first type is called direct variation. Generally speaking, it's of the form y equals kx. K is referred to as the variation constant, or sometimes it's called the constant of variation or the constant of proportionality. I tend to just call it the variation constant because that's the shortest. Anyway, what will happen in these situations is we will be given a description of a certain type of variation. Then we will be given some information which we will plug into the formula, which will allow us to determine what K, or the variation constant, is equal to in this particular case. Once we put that in, then there'll be a follow-up question that will allow us to use the formula to find the answer. All right, now, direct variation works like this. You've got y equals kx. Well, when x increases, so does y, so they go up together. If x decreases, so does y, so they go down together. So they go up or down together directly. All right, let's take a look at an example of a problem. This says free fall. An object in free fall, that is, it's just falling from space, travels a distance s that varies directly to the square of the time t. If an object falls 1,024 feet in 8 seconds, how far will it fall in 10 seconds? All right, so first of all, let me read this again. It says an object in free fall travels a distance s. So s equals distance, okay? And then it says it varies directly to the square of time t. So t equals time, okay? So we've got s for distance and t for time. It says that the distance it travels varies directly to the square of time. So s equals kt squared. Now, it's still in this form, but we're using s and t as our variables. K is not mentioned in this case. Quite often it isn't mentioned, but it's always present in all of these variation formulas. So now that we have this formula, let's go back and plug in the information. An object in free fall travels a distance s that varies directly to the square of time t. If an object falls 1,024 feet, so that would be s, or the distance, in 8 seconds, so that would be the time, how far will it fall in 10 seconds? Well, this first bit of information allows us to determine what k is. We've got 1,024 equals 8 squared would be 64, so 64 times k. Dividing both sides by 64, we get k equals, let's see here, what do we get? 1,024 divided by 64 equals 16. So now we're going to take this information and plug it back into that formula. So now our formula, now our formula becomes s equals 16t squared, okay? Now we have a follow-up question. It says, if an object falls 1,024 feet in 8 seconds, we already dealt with that, how far will it fall in 10 seconds? So now what we've got is S equals 16 times 10 squared. So S equals 16 times 100, or S equals 1600, and that is feet. So our final answer would be 1600 feet. All right, so that's direct variation. Y equals kx. X and y go up together, they go down together. Next type of variation is called inverse variation. Okay. Now, when you think of an inverse, there's an additive inverse, which is where they're opposites, or there's multiplicative inverses that are reciprocals. This is that latter case. It's sort of a reciprocal situation. The general formula for inverse variation is y equals k divided by x. In this case, when x increases, y decreases. When x decreases, y increases. So they travel in inverse directions, so to speak. All right, let's see here. We have an example. It says organ pipes. The frequency of vibration of air in an organ pipe is inversely proportional. Now, they use the word proportion and variation kind of interchangeably. So this says an organ pipe is inversely proportional to the length of the pipe. Another way we could say it is the frequency of vibration of air in an organ pipe varies inversely. So don't be thrown off by that proportional word. Okay, so we got the frequency of vibration. So let's see, we'll say F equals frequency of vibration. That's of the pipe. Inversely proportional to the length of the pipe. So L equals length of pipe. Okay. The frequency of vibration varies inversely to the length of the pipe. So we'd have F equals K divided by L. So it's of the same form, but we're using different variables. All right. It says if a pipe 2 feet long, so that would be L, vibrates 256 times per second, that would be F. How many times per second does a 6-foot pipe vibrate? Well, we can use this formula to solve for K. We'll multiply both sides by 2, and we get K equals 512. Okay, so now we're going to take that information and put it in here, which gives us F equals 512 divided by L. If a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? So L becomes 6. When we take 512 divided by 6, let's see what we get here. 512 divided by 6. Okay, 512 divided by 6. I'm getting 85.3 repeating, which is equivalent to 85 1/3. Recall that 1/3 is 0.3 repeating, 2/3 is 0.6 repeating. In WebAssign, you don't want to use a repeating and you don't want to use a rounding off decimal. You want to use pretty much mixed numbers or most likely improper fractions. But in this case, it's 85 1/3 times. So that is the frequency of vibration per second. All right. So again, inverse variation, one goes up, the other goes down, one goes down, the other goes up. Direct variation, they go up together, they go down together. Finally, the third type of variation we're going to look at today is called joint variation. Some of you might have a joint checking account, if you even have a checking account nowadays, which means that there's more than one person on that account. Joint variation in general looks like this: y equals kx w, okay? Or kxz, kx whatever. The point being, there's more than one variable on the right side of the formula, okay? So it's similar to direct variation, but you've got more than one variable on the right. Okay, let's take a look at an example. Talks about oil storage. So we've got a picture of this oil storage tank. And we're told that the height of the tank is 20 feet and the diameter of the tank is 15 feet. So obviously my drawing is not accurate. Interestingly enough, the picture in the book looks pretty much the same, not accurate. Okay, but the height is 20 feet, the diameter is 15 feet. It says, the number of gallons of oil that can be stored in a cylindrical tank varies jointly. So we're going to let G equal number of gallons, okay? Varies jointly as the height of the tank. We'll let H equal the height. And the square of the radius of its base, R, will be the radius. Okay, so G is the number of gallons, H is the height of the tank, and R is the radius of the base of the tank. All right, it says the number of gallons, so G, that can be stored in a cylindrical tank varies jointly as the height of the tank, so K, H, and the square of the radius, R squared. All right. The constant of proportionality, they're calling it, which is also the variation constant, is 23.5. So in this case, they're actually telling us what K is. Most of the time, they don't even mention it. Here, they're not only mentioning it, but telling you what it is. Okay. Find the number of gallons that can be stored in the cylindrical tank. All right, so we've got G equals 23.5 times H, which is the height of the tank, so that's the 20 feet, times R, which is the radius of the tank. Now, this is not the radius, it's the diameter. The radius would be what? Half of the diameter. So half of 15 would be 7.5 or 7.5. I'm going to use a decimal because it's easier to calculate that way. All right. So we've got, let's see here, 23.5 times 20 times 7.5. Oh, I forgot to square this. That is a common mistake that students make. Be very careful that you bring along any powers, squares, or cubes, or whatever. Okay. And I get 26,437.5, and that would be gallons. So this oil storage tank holds 26,437.5 gallons. All right, what I want to do now is go back and take a look at some situations where we'll be given a description in words, and then we'll write a formula. Then we'll be given a formula and write a description in words. Okay. This first one says, A varies directly as the square of P. So A equals K P squared. Again, K is present, though it's not mentioned. Okay, let's look at another one. It says Z varies inversely as the cube of t. So z equals k divided by t cubed. All righty. Let's take a look at another one. This says d varies jointly as r and t. So d equals k r t. And here we have p varies directly as the square of a and inversely as the cube of j. So we've got two kinds of variation going on at the same time. P equals ka squared over j cubed. We've got direct variation and inverse variation going on at the same time. Now we're going to look at a formula and write it out in words. R equals kt. We would say R varies directly as t. B equals k divided by h. B varies inversely as, inversely as h. And let's see here. P equals k m divided by n. So we would say P varies directly as, we need to put more space in there, directly as m, and inversely as n. So again, we've got more than one type of variation going on. All right, well, that's all I've got for you today. So again, this is section 8.9, variation. So your homework tonight is section 8.9, as well as working on the chapter review. I'll be back this afternoon at 1:15 with an office hour. Tomorrow, we'll review chapter 8 for a test on Monday. And again, a reminder, on Monday, there won't be an actual class meeting. You can take your test anytime from now until Monday night at 11:59 p.m. So have a great rest of the day, and I will stop the recording.